Ciao a tutti, sono molto felice di vedere tanti Pythonisti qui. In realtà originalmente ho voluto fare questo intervento in italiano, ma poi mi sono reso conto che italiano, sebbene è una lingua che sia utilizzata molto in Europa in cucina, ad esempio in tedesco, ceco, slovacco, non diciamo pasta lunga, pasta quadrata, pasta in forma organica o ornamentale, diciamo lasagne, spaghetti, no, non diciamo spaghetti, diciamo spaghetti. In tedesco, ceco, slovacco si dice spaghetti. Quindi in italiano è una lingua utilizzata molto in cucina o arte, ma in computazione c'è un'altra lingua che è più dominata, and that's the reason why I'm going to switch to English. If we stay in Italy, you have the huge mountains, Alps, but we are now here in Italy, we are at the south of Alps. But do you know which is the mountain of Alps that is most to the north and to the east? And that is over 2,000 meters. That's right, that's Schneeberg. What you see here, this is the view from somewhere between Bratislava and Vienna to the west. And the white mountain that you see, that is Schneeberg. And the stuff that is in front of that, these are some wind turbines. There are hundreds of them. And a wind turbine, this is something that not only generates energy, it also generates data. A lot of data. It is like an organism. It tells you, oh, I'm too hot, it is too cold here, I have too much energy, there are too many birds flying around. And even imagine that a wind turbine, of course it turns like this, it gets the wind, but it has a sensor that if the wind doesn't come from here, but it comes from here, it turns around. And then the wind comes from there, it turns around again. And then it turns around with the wind, but at some point, well, I don't have the right microphone to show it to you, but imagine that I have a microphone with a cable. I would have a problem with the cable. Because the wind turbine, if it turns too much to the right or to the left, then the cables, they have some length that are allowed to turn several times. But after 3 times, the wind turbine will tell, wait, there is wind, but wait, now I have to turn around back 3 times in order not to break my cables. And even there is one turbine that you can go there and visit. You can just climb the stairs, and you are not on the top of it. To get to the top, this is not so easy for mortal humans. But there is, if you see on the shadow, there is a small ring below where you can just walk up stairs and then see how this works. But now back to the data. Let's say that the wind turbine sends me CSV files. I will show you one CSV file. This is how such a CSV file looks like. It's long, very long, and it's narrow. So if we zoom into it, you will see that there are actually 3 relevant columns. There is something like a timestamp. The second column is actually the data, exactly the parameter that it consists of the device and of the parameter or of the physical entity. And the last one is the value. But now here you see that the problem is that if you want to put this, for example, into Pandas or into database, the first column, okay, that's timestamp. The second one is some string. And the third one, is it float? But sometimes you have data that comes as an integer. Sometimes they should come as a Boolean. But if you put all of these into one single table, then the third column will be a float, and if it tells you, for example, that here is an amount of 3 of something, then the float can be shown as 2.99999 something at the end, because that's how float works. So this is for the wind. What in my job, I don't only work with wind data, I also work with PV plants. And PV plant, if we are playing with languages, there is anyone speaks some Chinese here? There is the Chinese word yang, and the sign, it looks like an animal with horns. And this word yang, it means at the same time, it means a goat and a sheep. There is if you want to be very specific in Chinese, you have to use a mountain goat or a shanyang, that is goat, and a mianyang, that is sheep. but well, if some languages don't distinguish between the two, the people who own or who maintain PV plants, they know very well what is the difference between a goat and a sheep. Sheep, peaceful, very happy. There is grass, it can eat it, and it stays below the PV panels. But the goat likes to jump and destroy them. PV plant also sends us a lot of data, and if we visualize a CSV file, it can look like this. And if I told you that wind turbine was more like an animal that has some feelings and some states, then a PV plant is more like a plant. So something that is like a mass, that is a structure, but it's a mass. It doesn't have some central brain. And when we look more specifically at this data, at the files, you will see that there is some date and time zone, depends on where you get this data from. But then all the parameters that come from it are in columns. And now imagine a PV plant. If it is twice as large, then it will have twice as many components. There are different components, transformers, inverters, plenty of sensors that do a lot of stuff. But all of them are somehow numbered. And then if you have, for example, a thermometer somewhere, then all over you will have 20 thermometers, and all of them will give you some temperature of the panels, of below the panels, of the ambient temperature, and so on. And all of them will appear as extra columns. So you will have a very wide table. In this case, I can tell you we have some Austrian PV plants that give us CSV files with 8,000, 10,000 columns. There are people who want to open this in Excel. Even if you put this into database with 10,000 columns, good luck writing SQL on that. So we have seen the two extrema. And, well, there are now two hard problems in computer sciences. Who knows it? It's the cache invalidation. The problem with cache invalidation, well, for my talk, I had to adapt this a little bit. I was searching where I could find this cache invalidation in this. Imagine that if you have one long table that always when something gives you some information, you just put it there, then it's easy, because if something doesn't give you information, then you just don't put it into the CSV file, and it's okay. But if you have this white table, then every time you will have, every second, every minute, you will have to give this 10,000 columns, so 10,000 values. And if there is something that doesn't give you the information, you will have to decide, do I put null? Do I put something else? Do I repeat the value that was there before? And then you will have to interpret it. So usually we are talking about 3 dimensions. You have timestamp. Timestamp is something that increases every second, every minute. And you have device and parameter. And we have seen that there was the idea of the device and the parameter. So parameter is something like temperature, power output, wind speed, wind direction, and so on. They were concatenated into a single field. But it makes sense actually to divide it into more fields, because if you have something that measures the wind, speed, and direction, then you can have 100 of them, and all of them give you 2 parameters. All of them give you 2 wind direction and then wind speed. So if we look at this, what we received from the wind turbine, you see that in the second column, the series, you have this concatenated, this device and parameter, which is possible, but you lose the information about, well, I have 100 devices that measure the wind speed and wind direction. I would like to have this normalized a little bit. If we now take this other extreme with the 8,000 columns, of course, you have a problem. If you enlarge your power plant and you add a few more devices, then you will have to change the structure of your database, rewrite or SQL. You don't want to do it. But I was searching, well, what would be the best compromise? And this is what I found, actually. I go and group the data according to the type of the device. The first table on the left, this is the anemometer that measures something with wind. And there are always 2 columns. I have the timestamp and the device, and then the 2 physical columns. And I know that wind speed, it is always float, and wind direction, let's say, it's always integer. You don't need a float for that. And for temperature, you have always only 1 column. So you will always have 2 plus 1 or more columns that will give you the complete information about the type of the device. as I said, with the 3-dimension time step is something that will increase every second. Device is something that can change because you can add new devices or remove the devices, pause the devices, and then they will just not appear there. But every anemometer always gives you these two physical values. Every thermometer gives you one value, and there are devices that give you more values. So this is also nice that solves actually the problem with cache invalidation, because every sensor that is there that gives you the information, if it is not there, it doesn't give you the information, and then you don't have holes that you have to solve what I'm going to write there. The second problem in computer science is naming things. So this is nice. We have something in English. That's why I told you that, well, Italian with all the accents, this is something that is maybe something that you would like to use English or language that doesn't use all the accents for naming such things. Don't forget, names of people cannot be invalid. So if someone's last name is Šedivý, then write it as Šedivý, not as Šedivý. And then we have some other values that, or some other parameters that come from the input. So we have ambient temperature, and you see this is already a little bit not so ASCII. Well, you have spaces, you have square brackets, but you have already these circles for degrees, and you can have longer names, you can have different ways of writing, describing some parameters, and even you will have something that is maybe in a different language. And this is something that finally we can get use of a nice animal that will help us to solve this, and that's Python. In Python, a variable name must be something that is a string, that is not also a string, that is an identifier. But if you say that something is an identifier, which means that it can be used as a variable name in Python, which means that there are no spaces, there is only letters or letters, digits and underscore, and it doesn't start with a digit, then you are on the safe side, because if it works for Python, then it works for Databricks, it works for databases, for PostgreSQL. You can name files according to that. You are on the safe side. If it is ASCII, well, for physical parameters, you usually don't need something beyond ASCII, except for angstrom, but we don't use angstrom here. And is lowercase, well, this solves the issue with uppercase L, O, and 0, and so on, so they look quite well. But what can we do with this subset of data, of columns? We would like to normalize them somehow. Anyone knows the program called GraphViz? This is very useful if you have any problem with plenty of data and you would like to find the dependencies or visualize and find the dependencies or relations between data. GraphViz is a language that, well, is a text language. You write this file, you pass it via GraphViz, and it will give you SVG, PDF, or some graphic that you can visualize. And if I give it here, so it means that I divide split every word by underscore, and then split it, and then look what are the dependencies, then I will immediately get this. And you will see that there are some things that repeat. That for example, temperature of the main oil tank in Celsius, supplementary, and so on. So you see that there are arrows, and if you want to find a nice system of naming stuff, then find a nice hierarchy. So I will now jump to the result, where I looked at every single thing and tried to make the naming of the things as short as possible, and this is what was my result. You see that at every word, at the very end, there is the unit. Just before it, there is the noun that describes what it is about, and then you have something that is more or more specific, so less general. And you see the main supplementary oil tank temperature in degrees Celsius. So you try in your system, in your knowledge base, to find the smallest graph that covers all variable names that you have. And in the result, you actually want to have as few connections in this visualization as possible. Because it's perfect if after temperature there is always degrees Celsius. If you have some manufacturer that gives you the temperature in Fahrenheit or in Kelvin, then, and your internal standard is in Celsius, then you want to convert it. When you import a variable that says external temperature in Fahrenheit, then you want to name it external temperature degrees Celsius, and when importing, you want to calculate the difference. And that's it. So this is graphics. I think this is very useful also if just not connecting to the topic, but if you have some project and you want to find the dependencies, all you do is in the language on the top, you define the tasks, and immediately you visualize how the results looks like, and you see, oh, there are things that should be connected and they are not. You just add it to the source code, reprocess it, and the result will show you immediately where the connections are. So we were now with the two hard problems in computer science. Is there any more problem that you are aware of? Yes, it is off by 1 error. If we look at the data that comes from some energy meter, for example, and you get this, okay, this is in Spanish, but the first column is the timestamp, and then the second column, IV, this is actually how one Spanish manufacturer distinguishes between daylight saving time and standard time. I means invierno, so in winter, but we are now in summer, so actually when I created these slides, I made an error. And the last one is some variable, not important. But now, tell me, what is the best way to aggregate these numbers by day? In Pandas or in some other language, in SQL and so, you would maybe just take the first column, you would extract the date out of it and group by and make the sum. But the problem is with the line, with the two middle lines, for example, the line with the 23rd of May 0000. What is it? It is the 15 minutes of before midnight, or is it 15 minutes after midnight? If you usually in measurements, you measure something, and then at the end of the 15 minutes, you look at the sum and you write it down. So actually, this represents the 15 minutes before midnight. And you shouldn't aggregate it to the next day. You should aggregate it to the day before. So this is something that you have to distinguish between two types of values. And I found this graph that, well, a random graph that represents the temperature and precipitation. Everything that represents a state, so a temperature, wind speed, a speed of a car, is something that is instantaneous, usually. And if I am missing a value, I can usually interpolate between the value before that, after that, usually it will be more or less okay. But you cannot have the yearly temperature. There is no sum of yearly temperature. There can be maximum, minimum, or average. But for the precipitation, this is exactly the amount of some material or something that has been created, energy, during a time. So for our timestamps here, I would like to define somehow that the 15 minutes are not starting or ending somewhere. That are the 15 minutes that are defined in my timeline. How do I do that? In Pandas, everyone who works with Pandas knows that there is this timestamp. But who of you has ever worked with period, with a type of period? And this is exactly the time-related unit or object that allows you to work with something that has a period that starts somewhere and ends somewhere, and that is regular. So for example, if I do PD period now D, I define a variable that is a day, length of day, that is defined for today. If I can even ask for the start time and end time, and it will give me the first millisecond, nanosecond probably, and the last, no, microsecond, nanosecond. The first nanosecond and the last nanosecond of this. But the period itself, it is something that will cover the whole day. And also I can do simple mathematics with it, because I have the period representing today, and I can do -1 + 1, and I'm adding whole days. I am not, this -1, I don't have to define, take a timestamp and add 1 day, subtract 1 day. It is I'm adding or removing or subtracting integers that represent these periods. I have periods of any length. So for example, if I do Y, so it's a year, it gives me the current year. And you see the second parameter of the result is a Y minus December, which is a concept of a year ending in December. If you have some financial years that start, for example, in April or in October, then you can define it as a year that ends in March, that ends in September, and then it will calculate with them, and it will cover them, and you can do all the calculations with that. There are also quartals. So quartal standard is a Q minus dec. It means that the year ends in December. So my quartals are defined by 3 months of the year, but you can also move that around. For months, okay, that's, well, months. Then there is, you see this week. This is also possibility to define weeks that end on Sunday or on Saturday. Days, we saw them already, and hours and minutes and seconds, and also something in between. There is, however, something that I would like. When I discovered this, I was very happy. I refactored my code, and it worked. It was much more compact and self-explaining. But I had an issue. For some reason, I needed to divide a day into blocks of 8 hours, so into 3 blocks. Now, if I say I want the current hour, now we are after 12 o'clock, okay, it gives me this. This is the hour of between 12 and 13. If I tell it, give me a block of 8 hours, I would like from midnight to 8, 8 to 16, 16 to midnight, but it actually looked at where I am now, and it told me, well, the block is starting now. So it's from 12 to 20. If I do -1, it moves from 4 to 12. And this is not what I wanted. I wanted to divide a day by 6 days, by 6 hours, 8 hours, 12 hours. I wanted to do it now in 8 hours. So the shortest piece of code that I found was this. I even wrote a suggestion last year, maybe, to GitHub to find some way of describing it shorter, because here I have to put these 8 hours twice in my code. But there was, until now, no reply. Maybe I should program it myself. That's how open source works. The periods, using periods in your code is something that helps you to tell every method what to use and what you expect back. So for example, if you want a method to read some data from somewhere and normalize it into periods, then I would suggest to create a period range. So actually something like datetime index, but with period, well, a period index, and define it explicitly what you want in that, and then pass it to the function. And then the function should return a data frame, and actually the data frame should have the index that is exactly the same that you ask it for. And with this, you can very easily ask, for example, for the 3 days until yesterday, so the 3 periods of daily periods that are until yesterday, or for example, year to date, which means that all daily periods from the beginning of the year until yesterday. And that's it. Keep your data frames in good shape. Thank you very much. Thank you.